Hello, this is a demonstration and tutorial on the Audio Spline plugin I created, which has debug features, which can also be seen when playing in editor if needed. Interpolation for handling tight curves in spline points. Varying player detection types to ensure the spline isn't updating when the player isn't near the spline and can't hear the sound. And spline widening, which pushes out two sounds either side of the closest spline point, giving the sound a wider stereo image. So moving on to the tutorial, what we've got here is a blank area of the map and a few assets that we'll need for the sound. We've got a stream sound here, a meta sound, and attenuation. So if I right click and create a blueprint class from the audio spline, I'm going to rename that as BP_spline demo. Open that up, zoom in to the spline component, and you can see the default debug for the spline there. And the audio component, I'm going to add in the meta sound. If you go into class defaults, you'll see all the parameters that we can change for the audio spline here. A lot of these can be changed on the instance, so you don't need to change them in the class. The only thing that can only be changed in the class is the debug properties. So the first thing I'll go over is the debug. So the reason for it is so you can see the spline easily when playing in editor, and also when you're just using the editor itself. So if we turn on the show debug here, we'll change this to bluey, light blue color, and we'll keep this to this reddy orange. And the points here, you can change the size of these, so you can see them at the ends there, and this is the line connecting those points. So if we change that to 20, they're not visible here, but you'll be able to see it in the viewport of the editor when we jump over to that. So if we drag this in, you can see the debug here, you can see the points, and you can see the debug line connecting these as well. So we can extend that out as we need. And as I said, with the debug properties, you need to change those on the class. The only thing you'll see on the instance is the ability to turn it on and off. So that is the colors, and then you can change the line thickness and the point size. We've also got the distance increment, and what this does is increases the step between the debug lines that are drawn. So if we go over to this viewport here, you can see this sawtooth edge at the side. So these are the small lines at each step that have been defined by the distance increment. So if I change this to a larger value, say 200, you can see there's less of these lines, but then you'll cut off these corners here, so you can see where the spline goes round. So you'll need to set whatever is suitable for your needs. I've found that 70 is a good middle ground there. So you can see all those little sawtooth edges are back. So that's the debug. So the next thing that we'll go on to is the interpolation. So the purpose of the interpolation is to alleviate any sharp jumps in the sound from one position to another. So if the player's closest spline point location jumps from here to here, this stops it jumping instantly, which might cause clicks, and instead it slowly interpolates between those points. So the way that you set that distance as well is by using distance to interp. So if you increase that, the spline point would need to jump a longer distance before it uses interpolation. And if you keep it at a lower value, it will interpolate more often. So at 50, if I went from where my cursor is now to there, it wouldn't interpolate. But if I went from there to there, it would interpolate. And the interp speed would be based on how fast your player can move. So if I show you these default properties now, we'll jump into the editor. If I move slowly back and forwards, you can see that it's moving smoothly with me because it's not interpolating. But if I jump over to here, you can see it doesn't do an instant jump. It moves smoothly from one point to the other. Then if I change this to a very large interpolate distance, you can see it doesn't interpolate at all, it just jumps instantly. So you need to change these parameters to what makes sense for you, and you can hide these properties and reveal them as you wish. So that's the interpolation. Next is the player detection type, and what is really relevant to this section is also the attenuation distance and update frequency. This attenuation distance needs to be set to whatever is in your attenuation, just so that the player can't enter the sphere of the attenuation without it updating. So make sure this is set to whatever's in your attenuation. I've got 4,000 units set for the stream, so I've just entered that in here. And the update frequency as well. If you set it to 0, the spline will update at frame rate, as we saw earlier when I demonstrate the interpolation. If I set it to 1, it would be 1 second. So if I jump in here, you can see it jumping at 1 second intervals. So then coming back to the player detection type, there's 2 player detection types you can use. There's trigger volume or there's distance. So the trigger volume, if you turn on the box trigger visible here, so if I zoom out, you can see this box trigger. So whenever the player enters this box, the spline will start updating. Whenever the player leaves the box, the spline won't update. And the purpose for this is if you've got a lot of splines in your level, you don't want them all updating when the player can't even hear the sound. So by triggering the sound based on a collision box, you can turn the spline on and off when it's relevant to the player. And this also will change as you change the spline. So if I change a spline point here, you can see that the box moves out. And as we've set it at 4,000, each spline point is 4,000 units away from the edge of the box. So if I change the attenuation distance here, you can see that the box also changes size. I'll change that back to 4,000. And then after you're done with that, you can turn off the box. So then I'm outside the box now, as you can see, and if I play from here, the sound's inaudible, and you can see it's not moving on the spline, it's not updating. But then if I enter the trigger box area, you should see that start to update. So now it started updating, it started following the player. It's still set to our 1 second interval, so it's jumping at the moment. But if I change that back to 0, it should be more smooth. But that's basically the trigger volume detection type. If I change this to distance, this will change the tick rate based on how far the player is away from the spline. So your max player speed is quite important here. So if you set whatever the max player speed is, it will ensure that the player can't get into the attenuation radius of the sound without it ticking the defined update frequency. So if I was to play the game and I was in the attenuation radius, it will tick at whatever the update frequency is. If I'm outside of the attenuation radius, it'll tick at a rate that is the slowest rate before the player can quickly zoom into the attenuation radius. So as I go further out, say here it might be 1 second, here it might be 2 seconds, 3 seconds. So then it doesn't need to update more than is required. So if the player's out here, they can't quickly zoom into here without it starting to tick at the update frequency. So you can choose whichever detection type works for you. Trigger volume seems to make more sense to me because then it only ticks when is absolutely necessary, whereas distance will still tick when the player is outside of the spline attenuation radius, but just at a slower rate. The last thing to go over is the spline widening. So spline widening works akin to 3D stereo spread in attenuation. So if I open up the attenuation here, so we've got 3D stereo spread, and what this does is it takes a stereo sound and it will split the channels of that stereo sound at a width that's relevant to the player's distance from the sound. So if I go back to the spline widening function here, so this does something similar where it will create two adjacent sounds to the sound that's playing at the closest spline point to the player, and those sounds will follow the spline as well. So it might be easier if I demonstrate. So jumping into the editor, we've got the middle sound, which is the closest spline point to the player, and we've got two adjacent sounds that follow the spline as well. So it creates a bit of width to the sound. So this might be good if you've got something that's quite large visually, so an ocean or a line of trees, something like that. The downsides to this is that it uses two extra audio channels. So if you've got the audio channels to spare, it would be great. If not, probably not wise to use it. You'd also only use it in special cases. Most of the time you could make do with non-spatialized radius or the 3D stereo spread if you've got a stereo sound. But in special cases you can use this. So for something like an ocean, it might work where you want it to be really wide, you've got multiple waves going on. It could be quite useful. So the parameters that we've got on this, we've got the adjacent sound volume, which we can turn up and down. We've got the distance from the closest spline point. So if I widen this out and I play in editor, I can adjust these as we're playing. So I can make it wider and push out these sounds, or I can bring them back together and make it a bit tighter. And then, as mentioned earlier, they all follow the spline as well. The next properties on this that are important to set are the start time and the adjacent sound start time as well. So if I go to our meta sound here, see I've got an input parameter which is start time, and on our stream we can see that it's 29 seconds. So we don't want all these sounds playing at exactly the same time because you might get phasing then. This was the reason that I didn't use source buses and an audio bus, because it would play the sound all at the same time and it would create phasing. So by using the start time parameter, we can play the sound wave at different points in the file. So adjacent sound 1 will play at 5 seconds into the file. Adjacent sound 2 will play at 10 seconds into the file. And the sound that plays at the closest spline point to the player, that will play at the start of the sound file. So by doing that, we alleviate any phasing and we get variety in the sound as well. So make sure the start time parameter is set and these times are varied as well. And the last thing is use end volume attenuation. So what this does is, if you get closer to the end of the spline, you can see that end sound, it stops at the end of the spline, but then it will also attenuate the volume as you get to the end. So if you can see I'm at the end now, that adjacent sound has completely faded out and we've just got the closest spline point to the player sound playing. And then if I come back in, you'll see it starts to fade in until it's fully audible as we move across the spline. And it does the same with the sound on the other side, slowly fades it out and then back in again. You can turn that off, but then if you get to the end of the spline, you've got two sounds playing at the same location. So use that you wish if it sounds right, or you can turn it off if you're not finding it useful. So that's all the features on the audio spline. Hopefully some of those help with efficiency and also tailoring it to what you want it to do and what your needs are. So thanks for watching, and I hope that's useful.